Okay, so this video is going to be about doing a question about piecewise linear functions. So I'm going to do this question here. It says the temperature T degrees of a liquid of chemical reaction is a function of time T, where T is measured in seconds, and the time since the experiment started. Function is given by, and then we've got this piecewise function T is equal to, and it's 40 plus 2T between T is 0 and 30, and then it's 130 minus T when T is between 30 and 60. So there. Now, first of all, it says we've got to write down the initial temperature of the liquid. So in order to help with this, what I'm actually going to do is I'm going to plot this on my graph. So if you have the TI-84 Plus CE, then you can actually enter this function in a piecewise onto the calculator. So I'm going to demonstrate how you do this. What you do first is obviously turn the calculator on. Then you go to the graphing function, so press y is equal to, and then you need to enter in the graph here. But what you need to do first is press the math button, this one here, and then you need to go down to where it says piecewise, which is I think B. There, that one, B, piecewise, press enter. And then you need to choose the number of pieces. So in this graph, I've just got 2 pieces. So I'm going to change that with the left arrow key there to 2. And then I'm going to move down to OK and press enter. Now I've got the possibility to enter the 2 piecewise functions in here. Look. So the first one I'm going to enter in 40 plus 2t. So 40 and then plus 2, and it's going to be x because we're just doing a graph regularly. And then here is where I put in the limits. So my limits here need to be 0 is less than or equal to t is less than or equal to 30. So I'm going to put it in exactly like that, 0. Then to get the less than or equal to, I press the second and the math, and I want this one number 6. So I press 6 and then x, second, math, 6 again, and then 30. And that's entered in the first function. Let's just check I've got that right. 40 plus 2x, 4x is between 0 and 30. And I can use my cursor to go to the first one here. And then I want 130 minus x, and then this one needs to apply between 30 and again second, math, 6, x, second, math, 6 and 60. Okay, so now my function is entered. What I should probably do now is sort out my window. So what I'm going to do, I'm going to set my x min to be 0 and my x max to be 65. So we can see here that the minimum x is 0, here is 60, so I've just gone a little bit bigger to go up to 65. Then my y min, this is all going to be positive because it's a temperature. So I've got y min is 0 and then my y max is 130. I've set that because we've got 130 in the function here. So I'm going to choose those. Then I'm going to press graph. And I can see I've got my graph, my function comes up like this, meets as a maximum, then comes down there. So now I've got my function in my calculator. Everything else should be reasonably trivial. So it says write down the initial temperature of the liquid. So I could probably see that from the function that it's just going to be 40, but I can do it from the calculator. I can do calc, and then I want value, and when x is equal to 0. So that's when the time is 0, press that. And it will tell me when x is 0, y is 40. So that time there is initial temperature of the liquid, T is equal to 40. Okay, and it says find the temperature of the liquid after the 60 seconds. So I can do that by doing value again and then setting in 60 because that would be 60 seconds. And I can see there that it says when x is 60, y is 70. So T here is going to be 70. All right, that's going to be degrees as well. Yes, degrees C. Okay, then it says find the maximum temperature that the liquid reaches. So here I can now do a maximum function. So I can do second, calc, and then maximum, which is number 4. And I just need to choose my bounds. So my left bound, where is my cursor? There it is, it's way over there. So let me move it all the way back so it's on the left hand side of the peak. So somewhere there, my maximum is obviously going to be here. So move my left bound to there, press enter, right bound, move it to the other side, like that, press enter. Okay, so my peak is in between my bounds, then do enter, and it's told me here the maximum is 29.99998, so basically that's 30. So maximum temperature, oh, that's the time when that occurs, so the maximum temperature should be this one, 99.99996, so 100. Okay, then it says sketch the graph of t as a function of t. Now that should be trivial because I can just basically copy what I've got. So I saw that my graph went up like that and then it came down like that. Actually it's a bit, that's not quite right. That one should be higher up there. Let's move that one over a bit. Oops. Sort of more like that. Okay, I can also mark on what my maximums were. So I know that my maximum temperature was here. That is 130. If I want, I could write when that time was. That was when it was equal to 60. And I could also put in my initial temperature here, which was 40. Okay, so my scale is a bit suspect there. Let's move that down a bit. Put that down there. Make that 40 down there. So this is temperature in degrees C. This is time in seconds there. And then that goes up to, what's my highest time? It's up to, up to 60. That's not right then. That's 30. So I've done that wrong. That should be 30 there, and then that should be 60 there. Okay, so that's an acceptable sketch. So then it says find the time interval during which the temperature of the liquid is greater than or equal to 80. So what I want to do here is, if I draw another graph, so if I press y is equal to, and then I go down to y2, and I draw in another line at 80, I can then look for where the intersections of those are. So the time when it's greater than or equal to will be from this intersection here up to this intersection here. So I can use my calculator to find where this intersection is, find where this intersection is, and then it will be above 80 between those 2 points. So I can do second and calc and go down to number 5, which is intersect. First curve, let's move my cursor over to that. Second curve, guess, and then my intersect there is 20. So I'm going to mark the same thing on here. That's like that, that's at 80. And then that one there is at 20. And then I can work out that one as well. Second calc, intersect again, move my cursor over like so, and curve guess, and there it's got 50. So that one is 50. So therefore my time is, answer the question, find the interval during which the temperature of the liquid is greater than or equal to 80 is between here 20 and here 50. So T is greater than 80 when small t is greater than or equal to 20 and less than or equal to 50. Alright, and that should be the end.